Trace minerals can be classified into three categories: inorganic, organic, and hydroxy trace minerals. The differentiation is in the bonding of these minerals. When you have a simple inorganic trace mineral, the bonds are fairly weak, and in the rumen they come apart, and the copper and the zinc and the manganese are in a form that's available for other compounds to complex with. And that is a situation that we call antagonisms. And the second class that were developed were to, I'm going to say, make it possible to get through the rumen without the antagonists being able to complex with them. And I say it's kind of like putting a bubble around that element, the copper, the zinc, or the manganese. And this allows it to pass through the rumen. Then once it gets down to the stomach and small intestine, it releases the element in its elemental form, and it can be absorbed into the bloodstream of the animal. And there she takes charge of it and makes sure that she has enough to do her bodily functions. And another point with the trace minerals is that there's a very, very fine line between deficiency and toxicity. And so she has that ability called homeostasis to regulate the way these elements get into the small intestine. And so once an organic gets to that point, it releases the element copper, zinc, and manganese, and it has bypassed the rumen. The bubble has come off and it's available. Now the third class, the hydroxy trace minerals, they have a little bit simpler chemistry. With the organics, it's complexed with a proteinate, a sugar. It's something that they chemically do to protect that trace mineral. And it's bonded stronger so that it does not come apart in the rumen. But with the hydroxy trace minerals, it's simpler chemistry, and it is a strong bond, but it doesn't take quite as much to get it there. Consequently, these hydroxy trace minerals, the third classification, are not only very, very effective because their bioavailability is outstanding, but they are also more economical to use.